Okay, so we have already practiced using the limit definition of an integral to calculate the definite integral. Now we're going to go backwards. We're going to take the limit definition of an integral and we're going to convert it back into the definite integral. And this is going to help with our conceptual understanding of the structure of the limit definition of an integral. Again, this example in particular is pretty difficult. So the first thing we want to do is we want to isolate delta x. So there's something in this sum that we can pull out of the sum, out of the expression. And if we look at the denominator of this expression, we realize that we can pull an n out of 3in plus 2n squared. So this is actually equal to so basically all we did is we pulled the 1 over n to the outside. Now, we still have an n's on the inside of the summation, and we don't like that, so we're going to try to get rid of the n. And to get rid of these n's, we're going to multiply the numerator and the denominator by 1 over n. So this problem is difficult because we have to algebraically alter the expression given in order to get it into the structure that we want. So this limit is equal to limit as n approaches infinity, 1 over n times the sum of 9i over n plus 3 over 3i over n plus 2. So basically all we did is we multiplied the numerator and the denominator by 1 over n. And this is filthy because we basically just multiplied it by 1, so the expression is equivalent, but we got it into a structure that we like more. And from here, 9i over n and 3i over n both have I over n in them, and our delta x just happens to be 1 over n. So with this information, we can use our knowledge of the structure of the limit definition of an integral to realize that this is our xi. Our xi is I over n. So now we've identified our delta x equals 1 over n in our first step, and then xi equals I over n in our second step. So since xi equals I over n and there's no constant in it, we can identify that a equals 0 because xi equals a plus I delta x. So we know this is I delta x, and since there's no other constant, we know a must be 0. And then since the delta x equals b minus a over n, and it's 1 over n, and we know a is 0, what number minus 0 is equal to 1? And obviously it's 1. So we now have our b equals 1. So we know our a, we know our b, we know our delta x, and our xi. So now all we have to do is figure out our expression, f of x. So if we look at this, and we replace, instead of replacing x with xi, we're going to replace every instance we see xi with x. So we see 9 times, look at that, xi, I over n, 9x plus 3 over 3, and then it's another xi, so 3x plus 3, and we end up with 9x plus 3 over 3x plus 2. Sorry. So our f of x equals 9x plus 3 over 3x plus 2. And now we have all the information that we need to turn this limit definition of an integral into a definite integral. So the integral from a to b, 0 to 1 of f of x, 9x plus 3 over 3x plus 2 dx. So this integral long cut translates into this definite integral.